This is an example of calculating molarity. This is problem 520 in the Armstrong text. You're given 3.51 grams of sodium dihydrogen phosphate in 0.500 liters. So we've got 3 sig figs to deal with here. Well, what's actually in your solution? You want to get molarity. And molarity is moles of solute per liter of solvent. Let me get that right. Per liter of solution. And that's what the 0.5 liters represents. It represents the entire solution. So we know the volume of the solution. We don't know the moles of the solute, but we do know the grams of the solute. So if we simply set up what we have, we've got 3.51 grams of sodium dihydrogen phosphate in 0.5 liters of solution. We actually over here want moles of sodium dihydrogen phosphate per liter of solution. If we look at the units, the liters are okay, but we've got grams here and we have moles here. And we can convert from grams to moles, but we're not quite ready yet. We need to know the molar mass of sodium dihydrogen phosphate. So we have got NaH2PO4. I'm going to do this to 2 significant digits. Well, I'm going to do this to whole numbers. You should use the numbers that come in your text, which probably have 4 significant digits. Sodium is 23. The 2 hydrogens are 2. Phosphorus is 31. And all 4 oxygens will add up to 64. So my total here, carry 1, is 120. So there are 120 grams per mole. That will go with the grams, 1 mole. So in doing the math, I don't have my calculator here. Whoops. I will have 3.51, and I'll be dividing that by 0.5 times 120. And that will equal the molarity of my solute. And let me go run and get a calculator quick. Sorry that I'm holding this up. But I am going to do one other thing once we have this finished. 3.51 divided by 0.5, enter, and then divide that by 120. Okay, so I got 0.059, and I'm going to leave that in 2 significant digits. I'm sure the book wanted 3. But what you also need to be able to see from this is 0.059 molar sodium dihydrogen phosphate, and I have 1 mole of sodium ions for every 1 mole of NaH2PO4, and so my molarity of just sodium ions would be exactly the same, and my molarity of dihydrogen phosphate ions would be the same. You can look at this as being an ionic compound. This is your positive ion, and that's your negative ion. So that was the one other step that I wanted to do.